Now we want to prove equivalence between formulas. We have three cases. In the first case, we want to prove that P implies Q is equivalent with not P or Q. Okay, so we can prove equivalence with a truth table. We just need to evaluate both formulas in a shared table. And then we have to prove that in each and every interpretation, those two formulas have the same values. Both must be 0 or both must be 1 at the same time in every interpretation. Okay, so let's evaluate P implies Q first. As you know, this implication only evaluates to false if the left-hand side is 1 and the right-hand side is 0. In each and every other interpretation, it must evaluate to 1. Now let's evaluate the other formula, not P or Q. Well, not P evaluates to 1, 1, 0, 0. Since now we are evaluating a disjunction, if one of the operands is 1, then disjunction must be 1 immediately. In the remaining two interpretations, let's take the values of Q, and consequently, these are the values we get at the end. Okay, as you can see, the two formulas are equivalent. They have the same values in each and every interpretation. Actually, this is a very interesting fact. As you will see in the subsequent sections and modules of this lecture note, is that if two formulas are equivalent, they can be transformed to each other. This will mean that if we have an implication like that, we can transform it to a disjunction like that. So basically, we can get rid of implications and replace them with disjunctions. This was just a side note. Let's keep going. So let's evaluate the second pair of formulas, where the first one is not P implies Q. The second one is P or not Q. Well, I just erased the evaluation of P implies Q, but of course I do remember, and this is what we need to negate. So 0, 0, 1, 0. Then let's evaluate the other formula, P or not Q. Since P is 0 here, not Q is 1 here, the disjunction becomes 1. And we just found an interpretation where those two formulas evaluate to different values. Since we found such an interpretation, it means that those two formulas are not equivalent. So this means we don't have to continue. We don't have to deal with the rest of the interpretations. We found a counterexample. Those two formulas are not equivalent. Okay, so this concludes the second part of the exercise, and now let's evaluate the formulas in the third part. The first formula is not P or Q. The second formula is not P and not Q. Actually, this is a very famous equivalence. So I just, you know, this was a spoiler. Those two formulas are equivalent. We are going to prove that. And later on, in later modules, in these lecture notes, we will use this transformation of a disjunction to a conjunction whenever we will need that. But anyway, let's focus on the things we have to do here. Let's evaluate the first formula in the first interpretation. Well, of course, here the disjunction is 0. The negation of that is 1. And yeah, we can do it line by line. here not P is 1, not Q is 1, so the conjunction is 1. Exactly. So as you can see, those two values are the same. So we can go on. We can continue with the second interpretation because so far everything looks all right. In the second interpretation, yeah, the conjunction, sorry, the disjunction is 1. So if we negate it, we get 0. And let's evaluate the second formula. Not P is 1, not Q is 0. This means that the conjunction is 0. So again, also in this interpretation, the two values are the same. Let's continue with the third interpretation. It's not a surprise that the value is 0 here and the 0 here. So this third interpretation was quite the same as the second one. And now let's complete this exercise with the fourth interpretation. In the fourth one, the disjunction is definitely 1. So if we negate it, we get 0. And in this case, not P is 0. Therefore, automatically the conjunction is 0. So we are done. We just proved that those two formulas are equivalent as well.